mousetrap. First of all, the mousetrap has the same pieces of code that any other Sprite Maker has. It pulls in common. It pulls in the Sprite Maker code. I create a table called mousetrap. I could have called it public. I usually do, but in this case, I called it mousetrap. I load in the info, the sheets, the image sheets, all that good stuff for the graphics. I go through the same steps I always do to select the animation that I wish to play. The only animation I wanted out of the whole set was the forward-facing mousetrap. Let's go ahead and drop one, and I'll show it to you. The only one I wanted was the trap facing in this direction, and then as soon as I started it, I wanted to play the hinge moving and the little jumping, sort of like when a mousetrap fires, it jumps off the ground if nothing's on it, and that's what this does. So there are many more animations in the Reiner set, but I only wanted this one. So I set up the mousetrap, the base mousetrap animation, which has 9 frames. I wanted to play at 100 milliseconds per frame, loop once, and be done. I generate that sequence, and then my creator function is here. I, as usual, create a new sprite using the image sheet and the sequence data, just as I did. I select the front-facing animation, which is the one that I identified up here. And then I add a body. I make it dynamic, give it a radius of 20. I select the collision filter for traps. I make it a sensor, and the reason I make it a sensor is because I do not want it to get pushed around, and I don't want it to push the zombies. I merely want to detect the collision. In all other respects, it's simply in the world doing nothing, not interacting, not physically pushing on things. I mark it as a trap, and then I create a collision event. And the way the collision handler works is, in this case, I really do care if it's the began phase. I don't wish to accidentally fire more than once and start any of these other bits of code. Again, a piece of semi-redundant code. I check to see if it's a zombie or a skeleton. Of course, because of my collision code, it will only fire if it's one of these two. I could, again, comment this out, and the code would work the same. This is purely here for people who want to use a different methodology. All right. Thinking forward, I knew that the spike trap was going to have more than one triggering. It was going to be able to kill 3 zombies. So I said, okay, I'm going to take this code in a minute as I was writing it, and I'm going to use the same code over again for the spike trap. So I said, all right, let's just do this. Let's add a trigger count, and if the trigger count, let's see. What I said here was basically, if the trigger count exists, there's a field called trigger count, and it's greater than 0, do nothing, we'll return. Now you'll see when you look at the spike trap that this is the very same code, but it says greater than 3. So if it's greater than 3, somehow we've gotten into this code again when we were not supposed to. Should not make it that far, but things happen. Things get delayed, removals get delayed, callbacks get called additional times. It's for safety's sake, I put this code in here to prevent us from executing the code multiple times. For the mousetrap, the very first triggering is the only triggering. For the spike, 1, 2, 3, those are allowed. 4, 5, 6, not. So once it gets over 3, you're out of here. Don't come back. Then I set a field. So if I get this far, clearly I don't have a trigger count field. So I set the trigger count field to 1. So the next time around, if it somehow gets back in this code, it will abort early. Then I create a Sprite Listener. Now the reason I set up a Sprite Listener is I'm about to start the animation playing, and I don't want it to do anything until the animation is done. And the easiest way to handle that is to add a listener and then listen for the ended phase of the animation. And since I'm only playing one, that's all I got to check for. Now if I was doing multiple, as the leaf storm does, you'll see me adding additional code in here that says what sequence am I playing? Am I playing the rotating sequence? Am I playing the disappearing sequence? The leaf storm has a number of different animation sub-sequences. But in this case, what I'm saying is I played whatever animation I just started. I got to the ended phase. That animation just finished. Now I'm going to use a transition and I'm going to start immediately. I'm sorry, I'm going to wait 1 second, and then it's going to take 1 second because the default timer time is 1 second. I could just as well have said time 1000. So wait 1 second, and then over a period of 1 second, fade out from the current alpha to 0. In other words, wait a moment, and then make the trap fade out. And when the trap fades out, call whatever function is pointed to here, and that function is display remove. So from beginning to end, what occurs? You get in, you collide. Assuming you get this far, we mark the trigger to 1. We set up a Sprite Listener. We start playing the animation. The animation plays. It gets to the end phase. And then 1 second later, we start to fade out. 1 second after that, we finish fading out, and we destroy the trap. And the trap has been removed from the game. Done. Okay, so the other bits that this thing does down here below starting to play is it cancels the transition on the enemy. You remember when we shot the enemies with our arrows? What we needed to do was stop those enemies from moving. They were using a transition to move from point A to point B, and we wanted them to stop immediately as soon as they were killed. So the way we do that is we cancel the transition that is attached to the other, which is the enemy, which is being destroyed. So that stops their movement transition. We mark them as destroyed, and that's used by the AI code for the enemies. And when they see that marker, they don't keep trying to move the enemy. So we've canceled the transition, stops moving, and we've told the enemy, you're destroyed. Stop trying to follow the character. You're dead. And this is code we talked about before, but I just wanted to be clear. This is very similar, in a sense, to the arrow code. The only other thing left is, just like the arrow code, I have to play the correct animation on the enemy to make it look like it's falling apart, which is called the disintegrate animation. And if you look at the arrow code, you're going to see the very same code. I could probably have centralized all this, but I wrote this very quickly, so it ends up that I've got the same code in a few different places. And that is it. So our mouse traps are very simple. They sit there, they take one hit, they kill one enemy, and then 2 seconds later they're gone.
Very nice.
All right. So that is it. Next week, I'm going to come back with that document. I'm going to give you a brief overview just so you can see the parts. We're not going to go through the whole thing. I'm merely going to say this is how it's organized, and then we're going to spend the rest of our time looking at the changes that I will make, where we're now currently doing this with the keyboard. We will control this with a handheld joystick. I'm going to use the Xbox controller, the Windows controller for Xbox, but I'll be using D-pad and some buttons. So it'll be pretty universal as far as like PS4 joysticks or whatever people want to plug in. And I'll show you how to make that work with the joystick. And when I say joystick, what I mean is a controller. What's the right name?
Console controller?
Yeah, I think of it. Anyways, it's a normal D-pad plus joystick controller with buttons.
Yeah, right. There's a technical term for it, but we get that.
One more thing. I know we're over and you're about ready to close this down. Week after next is twin stick shooters. Unless things change, I'm going to come back with a partially complete to hopefully mostly complete twin stick shooter, which will derive from this code, and we will learn quickly how to do that. It's going to be very similar to this, so we won't have to do as much work to get a twin stick shooter working. And then I think we'll have satisfied 2 camps.
Okay, sounds good. I think this is good. So there you go. You need to go and check out the code for the leaf trap and for the spikes, and also review the rest of the code. One of the things I think is interesting as I'm looking at your screen here, Ed, is that each one of these functions, is a self-contained piece of code. There's you kind of go through it beginning to end, and overall, the amount of code needed to accomplish this is pretty small. But I like to see how you've got your project structured on the side. So in your scripts folder, you have everything broken out into these more of a modular sort of mindset.
I try very much for that.
Yeah.
In addition to having a module for each maker, many of these are what I would call a maker or a builder. So you have a maker for the leaf storm, whose job it is to create the entire thing, animate it, place it in the right location, all of that. In addition, you'll see that I tried as much as possible, where it was redundant to write the code over and over, was to create a sub or a master, or however you want to think of it, a parent class, I guess, that did a lot of the heavy lifting. If we look at Sprite Maker, and I won't go on and on here, but Sprite Maker. Here's Sprite Maker. Sprite Maker is a relatively short piece of code, but it's 100 lines of code. I could have written that 100 lines of code every time I made one of these, or I could have created a module where I created the functions, did most of the heavy lifting in here, and modified the code here to do just the different parts. And so that's what I decided to do.
Okay. So I think it's good to see not only the concepts and the code and see how things are coming together for the game, but also just to see how it's structured and get an idea of the project management into things, because that's always it's always a factor. No matter how well you think you've planned out the project, you still wind up having to manage all those little different pieces at the end. So.
Yeah, I believe that if people just take their time, and when they get the document from next week especially, they should be able to walk through the bits of this or look at the parts they care about and puzzle out what I've done. I mean, clearly it's going to take some time because this code is long and somewhat elaborate, but I do believe that most people of most levels will be able to puzzle this out fairly easily, just given enough time.
Okay. Sounds good. We'll be back here next Monday at 12 p.m. Pacific. We're going to talk about the controller, adding a controller so we can control things using an Xbox controller. So that sounds like fun. Until then, have a great week and happy coding.
Cheers.